Hi, and welcome to Cherry Pie Math. Today we're going to be talking about integers and just what they are, and we're going to be using integers throughout the rest of the year. We're also going to be using something called rationals. And I know those are really big vocabulary words. We're just going to deal with integers today, and it'll make a lot of sense once I start showing you examples. So first, I want to do an activity. I wrote a bunch of numbers here, and I want you to sort these into two groups. So pause the video and think about how would you make two groups from this group of numbers? Okay, I'm going to hope that you paused it, and if you're just here for the spoilers, that's totally fine. I understand. I would probably do the same thing. So hopefully you ended up with two groups that look like this. And it's okay if you didn't. We're just going to be using this kind of grouping for the rest of the lesson, but if you didn't, that's awesome still. So on the left, we have whole numbers, and on the right, we have fractions and decimals, which are kind of like the numbers in between the whole numbers, I guess. So we're going to be starting out with the counting numbers, those whole numbers here. So as you might have noticed, all of these have no decimals. There's no extra parts to it. And so counting numbers are the most basic form of numbers that you deal with. They're the ones that you learn when you're in kindergarten, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc., all the way until infinity. They represent amounts of stuff. So like you have 3 apples or you have 5 pencils. You don't have -5 pencils, right? They represent physical amounts that you're able to count, hence the name. There's also another way we call them. We call them the natural numbers, and we're going to be using that word later on in today's lesson as well. So examples of counting numbers include like 1, 2, 3, etc. But they also include like 3,124, for example, or 7,235,981. They're all positive numbers that are whole numbers that you count your way up there. 0 is actually not a counting number. The reason for that is if I ask you to count to 10, you don't say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You start with the number 1. So natural numbers start with the number 1 and go upwards. Whole numbers add on to that, and then integers add on to that even more. So for example, this is the definition of an integer. It's all whole numbers, negative counterparts, and 0. So we start with like the counting numbers, those natural numbers like 1, 2, 3, 4, 5, and obviously it still goes on, but I'm just going to go to 5. So those are called the natural numbers. I'm going to write that down. And then if we add on 0, which remember that's not a natural number, but it is a whole number, that represents our whole numbers. Any number that doesn't have a decimal, but with 0 as well, and is positive, is a whole number. Integers are all of these and their negative counterparts. So like -1, -2, -3, -4, -5, etc. All of these represent what we call integer values, integer numbers. So hopefully that chart helps you kind of see what's going on. We keep growing that set. So we start with those very basic counting numbers, those natural numbers, and then we have a 0 for the whole numbers, and then if you add those negative numbers in there, you get integers. None of these are decimals. None of these are fractions, at least in the way that we think about them. They're all just nice, pretty numbers with no extra parts on them. So examples of integers include like 7, but it also includes -7 or -1,345 or +5,000. I'm going to make that a semicolon so you can tell the difference between a comma and a semicolon. 5,681, for example. All of these are integers. The positive numbers, the negative numbers, and 0. They are not decimals. So for example, if I made it 7.1, that's no longer an integer. That's actually what we call a rational number, and I'm going to talk about that on the next slide. Or -35.42, that is not an integer because it is a fraction. Or a decimal, I guess. Well, decimals and fractions are basically the same thing, just different forms of each other. So for example, if I had -3/5, which is the same as -0.6, this is a non-integer. It is not one of those nice, pretty numbers. But if I had, let's say 12 over 3, that is an integer because this is really just equal to 4 and we have no extra things. So the value of it, I guess, is what makes the integer. It's just whatever it is without any extra parts, no extra fractions, no extra decimals, just a nice, pretty whole number that's positive or negative. One way to think about the way that these numbers work is by maybe thinking of like a Russian nesting doll. So we're going to start at this side actually, and we're going to work our way up all the way here. So this is the smallest part over here on this side, and then this is the biggest classifications on this side. So first we're going to just start out with the names. So let me change it to a black pen here. So we already talked about the natural numbers, and that's actually going to be the smallest classification. Next up, we have what we call the whole numbers, which again is just all those natural numbers with 0, and then that feeds into the integers, and integers feed into rationals. We also call rational numbers fractions. And then that feeds into what we call the real numbers, and that feeds into what we call complex numbers. And this is a lot of words. So I want you to pause as we go along and write these things down so you can keep track of what these different words are. And I'm going to be building onto that as well. Okay, so starting with natural numbers, I'm actually going to write down what the definition is. So natural numbers are just counting numbers. So like 1, 2, 3, blah, blah, blah. Whole numbers are the natural numbers plus 0. Integers are the whole numbers plus negative counterparts. Rational numbers are integers plus fractions. And on the next slide, I actually wrote it differently. So I'm going to write it both ways. I have integers and fractions, or the real definition, because technically you can put any number over 1 and it's still that number. Rationals are any number that can be a fraction. So like 4 is, even though that's an integer, that's also still a rational number because 4 over 1 can be written as a fraction. Real numbers are anything on the number line. And complex numbers are real numbers plus what we call imaginary numbers. Believe it or not, there are such things as imaginary numbers. We're not really going to be dealing with complex and real numbers this year. We're really just going to deal with rationals, which again are fractions, and integers. So we're really going to focus on those two this year. They all have special symbols. So natural numbers, you kind of draw an N and then you make a little bar there, and that stands for natural numbers. Whole numbers is kind of a weird one, so I'm just going to ignore that. Integers, I don't know why, but they are formed as a Z. That's an integer. Rational numbers are made by a Q with a bar there. Real numbers are an R with a bar there, and complex numbers are a C with the bar there. Whole numbers are just basically integers, so they don't even really come up with a symbol for it. These are the ones that you will maybe see when you're in high school. I just thought it'd be cool to see them now. And then when you're in high school, you can be like, oh my goodness, I saw this back when I was in 7th grade. So some examples of them. I'm not going to include the symbols here again, but you can go back in the video if you want to keep looking at them because they're kind of pretty. I kind of like drawing them. I really like drawing the integer one especially. So examples of natural numbers are 1, 2, 3, 4, blah, 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 infinity. Whole numbers are 0, 1, 2, 3, blah, 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 infinity. Integers are negative infinity, and like -3, -2, -1, 0, 1, 2, 3, up until infinity. Um, so it's just, as you can see, we're just building it up. As we go through each nesting doll, we're adding on a little bit more every time. Rational numbers, again, anything you can write as a fraction. So like 14 over 17 is a fraction, but so is 3 over 1. These are both examples of rational numbers. They're just anything you can write as a fraction. Real numbers is anything on a number line. So it's adding on to those fractions. You can put fractions on a number line, but you can also put numbers like pi, technically. Like if you look on a number line, you have 1, 2, 3, 4, and pi is 3.14 and a little bit more, and it never ends. You can't write pi as a fraction. It's impossible. You can get close, but you actually can't write pi. But it's still what's called a real number. It's right around there somewhere, right? So pi is a real number. Complex numbers are like 3 plus 2i. Okay, now that we wrote that down, I want you to draw a big X through those because I want you to see them, but I don't want you to worry about them. You're not going to be dealing with real numbers and complex numbers this year. I want you to know that they exist, but like I said before, we're really just focusing on integers this year and rationals this year, okay? So in summary, integers are just really any whole number, positive or negative, and zero. And I want you to also know that there are different classifications of numbers, but we're, like I said, like 4 times already, we're really just worrying about the rationals and the integers this year, or in other words, fractions and whole numbers. Next lesson, we're going to be talking about how to use those integers only, in operations like adding, subtracting, multiplying, dividing, just kind of a review from before. But I hope this helped you get ready for the rest of the year.